So this is the custom vision model that we've implemented. These are the training images that we've used. There are about 169 training images that we've used to train this model, and these are the tags on the side. Now in performance, we have 64.3% precision with 26.2% recall and 41% MAP. These are the individual AP ratings for each and every tag. Now the predictions, here are a few test cases for the predictions. So as you can see here, it can recognize two people looking to the side. In this case, it recognizes 3 people walking through the water. Note here, even though the person is getting hit by water, it is able to recognize the person. And in this final case, it recognizes the 2 people walking through the water. So this is the custom vision model that we've built, and this is the documentation of it. Now coming to the map system, we've used Bing Maps API, and this is the code that we've used to implement the system. It takes a GeoJSON file as input, and it maps the locations that are stored in the GeoJSON file. So here's the script in the browser, the script that we are running in the browser. So we navigate to the GeoJSON file that we've generated randomly to create test cases to test the code. So you drag and drop the GeoJSON file onto the browser, and immediately you can see that all the points are marked on the map. So we zoom in and we can see all the individual locations of people on the map. And this can be used to find out the density of people in given areas during disasters, so we can know where to concentrate our rescue efforts.
So I'll be talking about the drone processes and the mesh implementation of the drones. Now our drone had some certain basic requirements. It had to be GPS enabled, it had to have a 3-axis camera, an onboard SoC, and it should be able to connect to the base station. So we decided to choose a Matrix 210 from DJI. This kind of a drone is very useful in this type of natural disaster field and search and rescue, because it's a very robust drone and can endure various different environment conditions. It is IP43 dust and water resistance. Along with that, it also has an onboard GPS and supports for camera module. It also has an open SDK through which I've developed as you would say, a pseudocode which tells it where to go. Basically determines its path, and it's done using a Waypoint API. So the Waypoint API works by first subscribing the drone to the onboard SoC, and once the subscription is done, you can run a Waypoint initiation mission, which creates a initial object file, which is then run through a constructor and initialized to 0. All variables are called initialized to 0. Once that is done, we can move on to the creation of the various different waypoints. So yeah, this is the waypoint creation part, where we call this basic function which assigns the initial latitude and longitude to the thing and prints out that it has done that. After which we have used this algorithm to develop the path of it, and we have saved it as a file. And it is the inputs are read from the file, and it's saved as waypoints onto the drone. Now each waypoint has a certain action attached to it, and here we have set the order as it would first stay at its location for 20 seconds, then take a photo, turn towards the left by 90 degrees, and then take another photo, and then again stay at its position for 20 seconds, and then again turn towards 90 degrees until it has completed one rotation, and then it will move to the next waypoint. Now this is the flight control CPP, which is used to declare how the drone would take off, and it's basically has 2-3 different parts to it, wherein it would first run the basic process for it to take off, and then it would check if it has actually taken off. And here you can say second check in air, and in some cases it may not take off, but the system would think that it has taken off, so that's there. And then there's also a final check to again confirm that. And then we also have a monitored landing function so as to enable the drone to land when it's required. And again, it has the same checking procedures, as you can notice. And this is the main.cpp, which would first initialize all the basic variables, and then it would have a do while loop which will keep on asking the user to start the device, after which, once it's chosen, it would start the takeoff and then the various other activities that is involved. So where we also would like to talk on the FANET system, the mesh network system. We have implemented a Linux-based operating system called Byzantium, through which various different nodes can connect to each other and relay different type of information such as text and images.